Hi, welcome back to the breadboard. So I'm not normally one for doing mailbag kind of here's some stuff that I just got and let's open it up. I know some bloggers are and they're quite popular, but I haven't been up to now one of those kinds. But this occasion is a little more special. Many of you know I've been doing a power supply project over the last, I don't know, 4 to 6 months on my YouTube channel. And it's still going on, so don't worry, I'm not killing it or anything like that. We've got a ways to go with it. But I wanted to announce another project that I'm going to be starting up, which will be a combination of down in the lab, technical tutorials, learning about different devices, and a little bit out in my garage, because this project that I'm going to start on is going to be a CNC router. So we're going to go through things like linear rails, pulley systems, step-up motor control, using Gerber files to drive the X, Y, and Z axes, the different power supply options, you know, a whole bunch of things, and pretty much anything I can think of that would be related to setting up a home CNC router kind of system with an option of potentially putting a laser cutter on the head as well for doing paper patterns and etchings and engraving and things like that as well. So to that end, I approached RS-Componnets and they sponsor me some of the electronics for the project, which is what these big boxes are. So we're going to have a little look inside of what's there. And the other thing I wanted to just go through is a new company on the internet market called GearBest, and they're selling various Arduino electronic components, all sorts of things, through either eBay or AliExpress and various other channels, as well as directly. They approached me about would I be interested in reviewing some of their products that they sell, and I said, you know, sure, why not? Send them along to me. Here's the kind of things I'm working with, and I will have a look and present my opinions and what I thought of some of these things, and on my channel, and you know, we'll go from there. So it was no promises about giving them rave reviews or negative reviews or anything else. It's just send the products and I'll have a look at them. So that's what I've got in here. I've already taken them out of the envelope. It was just a great big plastic DHL bag. So we'll have a look at this as well after we've gone through the RS-Component stuff. I will be doing separate videos for the GearBest pieces as well, because there's some kits in here and things too, which I'll go through building, and some of them will be of great interest to some of the newcomers, because there's a, well, I won't spoil it for now, I'll save it for later, but anyway, there's some interesting things in here that I think some of you might be very interested in seeing. Anyway, yeah, first thing is, let's get these big RS-Componnets boxes opened up and see what we've got. Just want to clarify, by the way, this one is sitting on the floor, it's not on the bench. It's about 4 feet tall. And the reason for that is because I happen to know what some of the components are that are in here, and they're long. They're not heavy. This one I can lift up. It's pretty light, but they are long, so therefore it required the big box. This one, on the other hand, has got stickers all over it. Caution, heavy, heavy, heavy. It's about 20 kilograms in weight, so 40 odd pounds. About the weight of a medium-sized child. So it's a pretty heavy box, and it's got a lot of cool things in here. So let's get them open and have a look. We'll start with the big one so I can just get it out of the way, because I'll need the space. Okay, so this is the first one. Totally like shipping air. These are just little packing bags full of air bubbles. So okay, so the first thing we have is a whole bunch of hat DIN rail. So whenever you're building a control system and you're getting power supplies and various other things, you need to be able to mount them nice and firmly onto some kind of enclosure. And so between all of the industrial control systems I've been reviewing, and I have more coming, and the need to build a control system for the CNC, RS have sent me a whole bunch of hardware related to mounting the electronics to help me out, which is all of this cool DIN rail stuff. which is great. That's going to be very handy for the projects as well as the reviews for the industrial control. And then the other stuff we have in here is packs of trunking. So what you do with this is you screw it down onto the back panels with your DIN rails in between, and you can run all your cabling down through here. They come in packs of 4. I'll post links to all of the the bill of materials basically on the RS-Componnets website so that you can see for yourself. But these are really useful for keeping everything nice and neat and tidy once you've built them up, whether that be an industrial control, a home automation, CNC, whatever it is. It is always important to keep good control of your cabling to minimize interference, to make it much easier to maintain and update. And I think the other two are more of the same. Okay, box number 2. This is the heavy one. So this is the one that's full, more of electronics and everything, from what I've been reading on the packing manifest, but I'm not going to spoil any surprises beyond that. So, let's see, grab some of the bigger things first. So, here's another interesting component for when you're building CNC equipment. Is these rails to manage the cables when they go up onto the various moving parts of a CNC. What you have is these trunking, but it can actually roll, and it maintains its own shape in one direction. See how it stays vertical in that direction, but this way it's all floppy, and you run your cables down the inside of this, and it allows you to have your machine moving and keeping all your cables nice and thoroughly protected, and it keeps them all neat and tidy, which is essential when you're trying to have something with big moving blades and stuff like that flying around. So I've got a few of these to help with the build. So next thing we've got, as with any CNC equipment, you need to have power supplies and things like that. So I'm not going to go and look in all of these right now, but this looks like it's the DIN rail mount 48 watt power supply. So we're going to have a look at these on the bench in a moment, just so you don't feel like I'm just cheating you out here. It's just a bit difficult to have everything in view. So that's one. Another power supply. And you'll understand in a minute when I start explaining exactly what we're going to have with this project. A few little pink bags with things in them. It's like they're getting a bit beaten up in the transit here. So these are, according to this, nothing on that bag. Anyway, they're control boxes, yellow complete control boxes. So let's have a quick look in one of those. It's to say, well, no emergency system is complete without, no automation system is complete without having some kind of emergency stop mechanism. So there's a couple of bright yellow emergency stop buttons for it. Okay, there's some heavy items in here. Now these, without opening them right now, they're heavy enough. These are NEMA 24 stepper motors. So we'll have a look at those in a minute as well. There should be 4 of them in here, which there are. So there's 2 for the Y-axis, 1 for the X-axis, and 1 for the Z-axis. We then have a small power supply. This is for a different purpose, but it's still DIN rail mount, and we'll go through that in a second. DIN rail clip-on connectors. Again, when you're trying to wire things up nice and neatly, you need to make sure that you've got secure connections and stuff like that. Lots of little pink bags. I've never seen fuses to go with some of the DIN rail equipment I've got. So one of the things I'm doing with RS is reviewing a series of different industrial control PLCs, small ones, big ones, etc. And also with the CNC project, we need to have limit stops to prevent your X and Y axes if your computer went wrong for some reason running off the end. So what these are Hall effect sensors that you can use to detect the end of travel. When your metalwork gets near it, it will just set a open collector output and send a signal back to your control system to shut it down. So there's 4 of these, and we'll be playing with these in the industrial control PLCs as well as with the CNC project. We have 4 stepper motor control boards, 1 for each stepper motor. These are to interface logical controls up to high powered control, which is what the stepper motor inductive loads are, because they're only about 3 ohms or less, and they take quite a bit of power, you know, several amps. And your main supply voltage for the steppers is basically a 24 volt supply, so you need to have quality controllers to be able to keep the stepper motors running efficiently and smoothly. So we have 4 of those, 1 for each stepper. A whole bunch of connectors. I asked RS-Componnets to send me some connectors so that I can connect the stepper motors and also the sensors and not have to keep unsoldering or anything like that. I can actually put these on a panel and just unplug them. So we have some of those. A whole bunch of fused DIN rail connectors so that we can have power distribution but still have the circuits protected with proper fusing. There's a lot of little bags in here. These are end caps for the flexible cable trunking so that you can actually screw it down to your metal surfaces. So there's one for each, there's a pair for each cable trunk. And we'll have a look at that when we come to the point of mounting those things. Markers for your terminal blocks when you put them on your DIN rail. You can't see on this side, but they're all laddered and everything else so that when you do your diagrams you can keep track of exactly what's going to where. More connectors. These ones are 4-pin, so these will be for the stepper motors. So these are 3-pin. These are all 5 amps, so they're more than enough capacity to carry the power that we're going to be dealing with in this project. More DIN rail mount terminal connections. These are mounting kits for proximity switches. So we looked at the Hall effect proximity switches a minute ago, and these are the mounting brackets for them. These are sets of DIN rail terminal strips. These are more for the PLC reviews and everything else we do, so that I can set up some more permanent structure to review them and have sensors and everything hardwired, and we just switch out the controller rather than having to rewire and everything every time. Some of these will also be used, of course, on the CNC project to keep everything neat and tidy. So I have a bag full of those. End caps for the terminal strips, just so that you don't have exposed mains or anything like that. And we're almost empty here. So the 3-pin plug kits for the sensors, and some just different colored DIN rail mount clips. And finally, something that I actually cannot get in Canada is a connector block for quick connecting circuits, like for the mains, without having to mess around with screwing in a proper plug and things like that. And of course, this one is designed for the UK, so it has a UK plug on it, but it's also fused internally here. All right, and you're able to just clip your leads in live, negative, and earth. Got an indicator, and allows you, the minute you try and open it up, everything's disconnected. So this will allow me to do some little bit more work on the bench in safety. So I'll change this plug to a Canadian plug, of course, but that'll allow me to have a bit of quick disconnect. As I say, I've never been able to find them in Canada, even though the mains here is only 110 versus 220 in England, or 240. They just don't seem to provide them, so this will help out a lot. And that is pretty much an empty box now. Lots of garbage, an empty box. So we'll have a closer look at some of these items in just a second. Let me just get all this stuff out of the way. Okay, so I've basically broken down the boxes and pulled at least one item of each of the various products that have been sent to me from RS-Componnets for helping me with my CNC router project, as well as some industrial control PLC reviews that we're going to be doing. So let's start with the power supplies. I've got 2 kinds. One is a 24 volt 10 amp, so sorry, 48 volt at 10 amp power supply, so 480 watts, and I have 3 of these. Now you might wonder why I need so many of such a high voltage. Well, the stepper motors, these ones here, these are NEMA 24 compatible stepper motors, 1.8 degrees, 3.2 volts at 2 amps each, and they're 4-wire stepper motors, and I have controllers for those. But when you drive these things, even though the specifications say 3.2 volts at 2.8 amps, that is not what you drive them with. What you actually typically use is a high power supply like this one, 48 volts at 10 amps, and you drive them with pulses of current. So it's basically you drive the stepper motors as a current device, not as a voltage device. And the controllers, which in this case is the Gecko drive that is provided from RS-Componnets, is what manages the current limiting and phase driving and everything else into the stepper motor. So it basically converts the 48 volt 10 amp power supply into the right amount of power and current to drive the stepper motor. And by having a higher voltage, it allows you to get much higher torques out of your stepper motors without necessarily overloading them. Now, as we go through the builds and we talk about each individual area, you will start getting to see exactly what I mean by that, because I will go into a lot more detail. For now, we're just reviewing what the components are to start the electronic side of the build and evaluation. So yeah, the power supplies, I've got 2 of them are for driving the stepper motors. So like I said, you've got 3 amps each, and so basically I've got one power supply for 2 steppers, and I've got 4 steppers, so that's the 2 power supplies with a little bit of extra capacity in case I want to add things later on. And then the 3rd power supply is for driving a 48 volt spindle for the actual cutting head, because I'm going to have the option of driving a 110 volt spindle, a 48 volt spindle, or a 24 to 48 volt spindle, and also potentially a laser cutter as well, which will require its power supply all on its own. I don't want the noise from the stepper motors driving around and things interfering with the laser cutter, for instance, or the running of the spindle. So by isolating the power supplies from each other, it allows me to have much better control, and if one of them does stall, it doesn't start messing around with the other ones and making them fail as well. And then the other power supply that I have here is a smaller 24 volt 5 amp power supply, and the reason for this is that, as with a lot of industrial control solutions, the design nominal voltage for all of the equipment is actually 24 volts. So this will provide that to drive some of the equipment. And I actually have a industrial PC going to be coming to me soon for review, and I'm going to be using that as part of this solution as well for the CNC router once I'm done reviewing the industrial PC. It's a small fanless unit, and you'll see that once it arrives. But anyway, it's going to require 24 volt 5 amp supply too. And the PLCs that RS have been having me look at from various manufacturers have also all been requiring 24 volts to drive them, and some of them do come with their own little 24 volt DC power adapter, but I wanted to have one because not all of them do come with one. So by having a separate one that I can put onto a board along with some of the other equipment means I don't have to worry about whether they come with it or not. I can just run it straight from this one. So this one has plenty of capacity to run a small PLC unit and a few ancillary devices and things. As I say, 24 volts and 5 amps. Now, the one thing about both of these is they're DIN rail mounting. And what that means is, one of the things I was showing you when I was first pulling things out of the big box is you've got this railing, and if you look at the end of it, it's like a top hat shape, T-hat, like a T-shape. And this is called a DIN rail. And what this does is this will screw onto a back panel or into a large case or something and allow devices. So if you think of it being screwed down right now to the bench, even though it's not, just pretend that it is, then what happens is you get these. So this is screwed to a very solid structure of some kind. And then with these at the back, they have these tabs that will allow it to effectively click into place on a rail, and you just pull this out with a screwdriver or something. I can do it with my hand here, and you mount it on, and now it is solidly mounted. It's not going to come off unless I put a screwdriver in here and take it off deliberately. And the same with the big 48 volt 480 watt one. It mounts in the exact same way on a DIN rail, and you can see here it's, if I lift it up, it's clipped quite solidly underneath, and it's got support on either side of it. And this is the standard way of mounting a lot of industrial equipment, is you put them onto DIN rails like this, and you then have the wiring coming out. So this, in this case, this is the 24 volts out coming here. There's two terminals for the plus voltage output, and 2 for the negative rail, and then your mains is coming in on this side. This smaller unit has the mains coming in on this side, and the 24 volts coming out here. We also have a relay contact to say that the DC is okay on this side. So presumably this particular unit has a low voltage or power quality sensing in it, and will close a contact maybe so that you can let a PLC know that it's got some problems with its supply and that it should maybe shut down or something like that. So that's the power supplies that I've got for this, and that's why we have one for the programmable logic controllers and one for the big driving of the stepper motors and things like that. The other part to go with this, of course, as, while we're on the subject of DIN rail mounting of equipment, is you need to be able to run wiring. So the next part that I want to show you is we have these cable trunking, which what it is we were already looking at this before. It's basically a U-shaped trough that you can run. You screw this to the same panel backing as you would the DIN rails, and you would put it potentially in front of your power supply or something like that. All right, and you would bring the cables down and into the trunking, and then run them up to side trunking and things like that, so that you would keep everything all nice and neat instead of having wires flopping around everywhere. And this allows you to make some very, very neat cable management systems in your enclosures that you put your control systems into. So while we're on the subject of cable management and keeping things neat and DIN rails and basic infrastructure for control systems, the other part that I wanted to show you are various DIN rail mount terminal connectors, and these are the ones that I've got for this project. So let's start with a big one at the end here. This is a fused DIN rail mountable unit. It's just the top just unscrews. If I can get it to unscrew. I'll worry about that later. Anyway, the top unscrews, you put a standard small fuse in there. I have a little bag of 5 amp ones. And basically these mount onto the DIN rails, and they just, the same as everything else, they just clip on like that, and that's a nice now solid. It'll slide around a little bit, but that's fine. You can actually get little clamps that if you want, that can clamp either side with a screw fitting that will stop these moving, but basically they would go on the DIN rail like this. They won't come off easily unless you deliberately put a screwdriver in here, lift that tab, and then they'll come off quite easily. But once they're on, they're not going to come off on their own. And one of the things that you might be saying to yourself is, well, you've got all this side exposed, where there is, if you've got this as a mains fuse, then you've got mains exposed here. Well, the other part that comes with these things, these little caps, you can get them in a separate little bag. And what they can do is you just, if you've got an exposed end, then you can just clip these on like that, and now you have it nice and protected. All right. If you're stacking these, you only actually need one on the end of the line of them. So if you're putting more than one on, then you don't need the end cap until you get to the end. So they just clip on just like that, and you're pretty much done. Now the other ones that I have is for so that I'm using these for either the high voltage mains coming in, which I'm going to have that fused. I'm also using it for the higher powered 24 volts coming out. I'll put a slightly bigger fuse in here so that I protect the circuits a little bit. For a lot of the control signals, what I'm using is these little blocks. They come in blocks of 5, and again they are these ones are actually joined together in little blocks of 5. I don't know if you can see down there, but basically it's a strip of 5, and they're all connected. There's one solid bus down there. So what you would do is you would simply bring in 24 volts onto one of the pins, and then you can distribute your 24 or 48 volts, whatever it is, out on the other ones. They don't come apart, right? They're pretty solid, and it's a great way of doing, you know, a 24 out from, say, one of these power supplies, where if you want to feed it to a lot of different circuits, so we've got sensors and things like that, this can be providing you the positive supply rail. And I have 6 of these blocks, so I can use some for the plus 24 volts, plus 48 volts, as well as the grounding for a bus as well. And again, these just simply clip onto the rail in exactly the same way, right? And that's it. So they're now on. You can slide them up. They're perfectly safe to put them next to each other because they've got adequate insulation between them. And then the other ones I've got is I've just got 10 of each of these. They're just small individual ones for signals. So you can see that they're much, much smaller, and I've got them in different colors. And again, they just clip simply onto the rail and click into place, right? And you can slide them all up if you want to. I didn't click that one on properly. There you go. All right, and you just use screwdriver to make your connections, and you just start adding them up. And I have some labels as well, which will allow me to properly identify what is, you know, put numbers on them or something like that to identify which ones is what. So that's, you know, a next part for the DIN rail. And what else do I have that is DIN rail suitable? I think that's pretty much it for the basic DIN rail stuff. The next thing, as far as sticking to cable management is concerned, is this little baby here. Looks a little bit like a tank track. Okay, and what this is a flexible cable trunking. So it's very much similar lines to this that we were looking at before. The only difference is it's designed to be flexible. And if you think about a CNC system where you have a bed that is fixed, and then you have a gantry that has your cutter on. So maybe if you think about your axis being this way, and you want to be able to move this along either way so that your head can be cutting in an area, then what these do is you provide the ability to route your cables up through the inside of this trunking in a nice, neat, even curve, and up to the next solid piece that's working in this direction. And even though the work surface, you know, is moving along the rails, and these are basically a meter long, you can get almost a 2-meter range with these, because you can go right from this end, which is where I'm at now, and then you can go right down to that end. And you know, so that is quite a range of movement where you've got your cables protected. They're still very flexible, and you've got these little adapters that can go on the end, which they just clip into the ends of here, and they allow you to screw it down to your surface on each end. If for some reason you did need to have a longer one of these, then you can simply click another section, because they have like a male and a female end. You can click another section into it, and then you can just extend the length. And if you need it shorter, you can basically just pry out a few of the links. Think of a metal wristwatch band where you've got these little links where you can click them in and out to make the band the length that you need to suit your wrist. Well, the same thing applies to this. You can extend or shorten the length of the flexible trunking in order to suit the work surface that you're going to be using it with. And when we get to building the CNC bed and putting the rails on and things like that, you'll see exactly what I mean, and we'll go into a little more detail as well. And I've picked a size here that is big enough. You can get these into very, very huge, and you can actually get them a lot smaller than this as well. This is the smallest I wanted to go to, and still had enough comfort that I can get the cables I want into the end of this and up to the job. It always pays to go that extra bit, as far as one, you know, for safety for sure, and two, just to improve the reliability of your system that you're building. So, you know, invest in the extra. These are not cheap. They're not horribly expensive either. I think these are about 20 pounds, so about $40 per strip. And you would need 2 or 3 of them depending on what you're building. I think these particular ones I have here are about 20 pounds each. Now obviously if you're buying them in North America or in other places, they would be different prices. This is just because I'm looking on the RS-Componnets website from the UK, because it's the RS-Componnets that are kind enough to sponsor my project with this, and so they provided these parts for me. Okay, so here are some of the smaller items that arrived in the box. So starting with the more fun ones, what we have here are the NEMA 24 stepper motors, and these, as I said, are they're RS hybrid stepper motors. They're branded RS, and they provide 1.89 Newton meters of torque at 3.2 volts and consume about 2.8 amps, and they're 1.8 degrees of rotation per step. So that's each time you would phase through with the coils, it would rotate this 1.8 degrees, all right, as it goes round. Now what that results in is basically 200 steps per rotation. So depending on the gearing that you put on the outside of it, you can get very, very fine or very, very coarse control. So the X and Y axes, what I'm going to have is some pulleys on here, and you'll see as we start going through some of the mechanical build exactly what that involves. But these are high enough torque that I will be able to cut aluminum, plexiglass, obviously, you know, plywood and stuff like that also would be easy to cut with the strength of these. We've got two of these that are going to be driving the main Y axis, and then we've got one that's going to be driving across the gantry on the X axis, and there's going to be one driving a shaft which will be driving the Y axis, Z axis, which will actually have the cutting head on it to take it closer and further away from the job. So you actually will be able to cut in 3 dimensions, X, Y, and Z for this by the time we're done. Now obviously these stepper motors, they come with short wires, you know, that just come straight out of the side of the stepper motor. There's really, you know, that's obviously nowhere near long enough to get to the control system or anything like that. So you have to be able to extend this, and also you have to be able to disconnect with ease. So what I've got is I've got some plugs. I've got some 3-pin ones for my sensors, and I've got some, I don't know if that's focusing on there or not. Anyway, these are 3-pin Amphenol quick connectors, and I've also got some 4-pin ones. The 4-pin ones rated at 5 amps, and as I said, these are we only need about 2.8, so they're more than capable to carry the capacity. And I have the mounting parts for these. That's the 4-pin that would go onto the chassis of the control system, and basically they just click in, and then there's a part turn to lock it into place. That way it won't accidentally come out when the things are moving, because remember the cable on the end here is connected to the flexible trunking and then going up to the working surface. So there will be some clamping as well involved, obviously, but you don't want it to accidentally get pulled out with vibration or anything like that. So these have got quick connect twist locks on the connectors, so that prevents that from happening. And that's the same for the 3-pin and the 4-pin ones. All right, the 3-pin ones being for the sensors, which need plus 24 ground and the actual sensor output, and then the 4-pin ones being for the stepper motor control. Now the other end of the stepper motor control would have to be the control system. Your computer that's going to be controlling this is going to be TTL level logic, and so that's going to come in to the setting, the connections down here where you've got a step and a direction. So you have forward and reverse, and then you go step, step, step. Now what this drive does, this is a Microstep drive, so it actually does a depending on the settings that you set up, and there's some jumpers inside as well, and we'll look at that, as I say, when we go closer through the builds. You can set it to do micro-stepping, which gives you much, much smoother control with your stepper motors and much more accurate. So as I say, we're going to go into that a little bit later, but suffice to say that you need something that does micro-stepping for controlling your stepper motors to get more accurate and smoother drives on your steppers. And these are from RS. They're built by Gecko Drive, and they're the G201X Microstep drives. Okay, and as I say, we'll go into more details of how these work and what their specifications are once we start looking at how does a stepper motor work and things, and maybe we'll hook up an oscilloscope and look at the waveforms and everything else that's coming out of here. Okay, now it would be remiss of anybody building an automated system to not have emergency stop. So one of the things that I asked RS to send me was a couple of these, and what they are, basically you screw them in very clear and obvious, easy to access places around the workplace for the CNC machine, and if there's any problems whatsoever and you need to basically emergency stop the solution, you just hit the button on the top and it actually locks into place, and you have to twist it to release it to get things going again. All right, so these are going to be wired into the solution so that we have an emergency stop, probably one at the front and one at the side maybe, or something like that. Very important for anything where you've got complete autonomous control of basically power tools. You're going to have a high-powered cutter that's going to be running at several hundred watts of power, so it's going to be equivalent to a reasonably high-end router like a Ryobi or a Portacable or DeWalt or something like that. The big higher-powered current ones, and you don't want that to be getting snagged up into something and start wrecking the place or wrecking you. If you get your hand in the way or something, you want to be able to just reach out and wildly whack against the switch and just kill everything. So that's basically what these are for. Added safety, very essential for any automated project, is to make sure you have safety measures in place. So that's one of the things that we will be making sure that's there. Now, while we're talking about stepper motors and stopping things and stuff like that, the other part that I've got here, and there are many ways of doing this, is a Hall effect sensor. And what happens with this is you power it with 24 volts. It'll actually work anything from 10 volts up to 30 volts. But being an industrial control component, it's normally designed to work at 24. And it has a Hall sensor at the end. So any metal that comes within a couple of millimeters of the end of this will trip the sensor and send a signal back to say that it's got to its limit. So what these are going to be used for is to allow the logic controller to home back to a 0 position in the X, Y, and Z direction. So we're going to mount these in appropriate places on the CNC machine to make sure that we don't run off the end of a rail and crash into a stop or something like that. And I have enough of these to do one on each axis, not access, sorry. My accent's getting messed up a little bit there. And I think that I've gone through all of the components that have arrived so far. I will be, over the next few weeks, there are going to be other components arriving because I have a whole bunch of metal work that is coming from the USA. I'm actually basing the build on the Ox build, and I will provide a link to the site that has a whole bunch of different designs. My one that I'm going to build is going to be 5 feet by 5 feet overall size, which will allow me to take half of an 8 foot by 4 foot sheet of plywood or whatever other material I want to use. So basically 4 feet by 4 feet, put it on the bed and be able to cut it out to its full limits to make maximum use of it. And that's also about the biggest I can put into my garage without losing any space around it that I can move around and be safe. And one of the things I'll also be doing as we start going through these projects is, as I look at each part that I've got, whether it be the Gecko controller, whether it be the power supply or the stepper motor, we will do a comparison to some of the ones that you see for sale on eBay, especially with the power supplies. I've got these ones, and I've deliberately picked Radio Spares branded components, not only to keep the cost down a bit, but also because Radio Spares is sponsoring the project, of course, and I want to be able to advertise their name as part of the project as a thank you. But also, when I've got some cheaper Chinese ones which I ordered through eBay a little while ago, and I'm going to open these up, and we're going to have a look inside at the build quality of these, and then we're going to look inside at the build quality of the eBay specials that I've got. And they're not necessarily indicative of everything that you buy from eBay, but you will see some of the things that you have to be aware of when you're not buying, for want of a better word, first quality product. All right, I can get these from RS-Componnets, and I can trust the fact that they're going to be well built and they're going to be performing and meet the qualifications and certifications that they claim in the box. Like, these are both CE rated, so I can use them in Canada. The same as the even this stop switch. All right, the first one that I gave that I listed to RS-Componnets to send me, they actually weren't able to send it to Canada because it wasn't CE rated. So I had to find another one, which I did, which is this one. This is Schneider electric emergency stop button. But it just goes to show, though, that when you buy from a reputable vendor, they'll actually be looking out for you. And in this case, they highlighted to me that the one I was asking for was not certified for Canada, and therefore they were not willing to send it to me, and that I'd have to find a different product. Now, if I was ordering from eBay, they wouldn't probably give a crap. The vendor that you were dealing with would probably just say, okay, fine, you know, you buyer beware, here's what I'm claiming it is, and if you want to buy it, that's it. It's up to you to verify that it is fit for the job. And when we look at the power supplies, I've already looked at some of the ones I got from eBay, and I was a little shocked about what I saw inside. So we will go through that once we start looking at these power supplies. And what it will do to highlight to you is, yes, you can build things on a shoestring budget, but if you want to build something that is going to be reliable and that you're not going to have to worry about it going up in flames or failing halfway through an expensive job just because of a bad solder connection or something like that, then it is worth paying the extra money. You know, it's a one-off payment when you spend more money. Maybe these are like 2 or 3 times more expensive than something you might get from eBay, but all it takes is, you know, once or twice for a glitch because of a bad solder joint to ruin a cut on a bit of high quality aluminum or plexiglass or something like that, and you would have more than paid for that better quality power supply to have been put in there from day one and not have had that issue in the first place. And the same goes with the stepper motors. You know, there are NEMA 23s, 24s, 34s, etc. on eBay. They're a dime a dozen. You can get them very, very cheaply if you want, or very expensive. But you don't know what the quality is. Are they first quality, i.e. the ones that have passed the production line QA, or are they slight seconds where they still function, but maybe they're a little bit noisier on the bearings or something like that, or there's a little bit extra slippage, or they're slightly less power than what they're supposed to be, or something. You just don't know, and it's really a bit of a lucky dip. And I've been fortunate with some of the things I bought from eBay in the past, and that they've worked very, very well, and they've met the expectations that I've had. But you know, recently I've had an instance where I ordered some LED 8-segment LED displays with a little controller, SPI controller built into them, and I only ordered 4 of them, and they were only a few bucks, so it's not like it's really, really expensive or you know, so worrisome as far as costing me a lot of money. But only 2 out of the 4 worked. So the vendor's being very helpful. They're going to send me some replacements, but nevertheless, it indicates that you know, you're not always necessarily getting the best quality stuff. And if you're going to build something that you want to be able to rely on to make you money, maybe for doing you know, manufacturing of something, then you really want to make sure you spend the extra so that you don't have to worry about those things.